Hi everyone, I hope you're all doing well. I miss seeing you guys, so I just want to give you guys a quick hello before we get started. So we're going to work on L'Hopital's rule. So let me get over to the problems and I'll show you what I'm talking about. Apparently I don't know how to turn the webcam off, so you get to see my lovely dining room table lamp. So for these kinds of limits, there are sometimes times where if we were to evaluate it, we would get 0 over 0. So for instance, if we did 2 cubed minus 8 over 2 squared minus 4, we get 0 over 0. But that doesn't mean that the limit doesn't exist. It means that we need to use L'Hopital, L'Hospital. So what we're going to do instead is actually keep that same limit, x approaching 2, but we're going to take the derivative of the top over the derivative of the bottom. When we do that, then we can actually plug in 2 again. So 2 squared, 2 times 2, and we end up getting 3. So the limit existed all along. It just kind of looked like it wasn't going to because of that indeterminate form that we got, 0 over 0. So we can only use L'Hopital when you have 0 over 0 or infinity over infinity. Only those two actually work for us. Let's try another one. So what if we had the limit approaching infinity? So I have this e to the negative x ln of x. It looks like it's not going to do much, but I can actually rewrite this. So x approaching infinity, this is really a natural log of x divided by e to the x. And then if I were to actually evaluate this, natural log continues to go on, so that's going towards infinity. And then e to the x also continues to go on, so that's over infinity. What that means for us is we can use L'Hopital. So what I can do again is actually just take that derivative of the top, derivative of the bottom. Oops, infinity this time. So when I take the derivative of natural log, I get 1 over x divided by e to the x. Okay, so when I actually do this again, I can rewrite this a little bit, or I can just do the numerator and the denominator. So 1 over like infinity over e to the infinity, what's really happening is this whole thing is going to go to 0. So the entire limit is 0. And that one's done. So let's try another couple. I have 2 more for you. So if we're going for number 3, let's take a look at just limit x approaching 3 of x squared minus 4 over x plus 2. So we're going to evaluate just like what we're used to. 3 squared minus 4 over 3 plus 2 ends up giving us 3 squared over 4. Well, that's going to end up being a 5 for us over 5, which is just, not 9, which is actually just 1. That ends up working totally fine. I think I actually meant to do something else though, which is kind of annoying. So what if I ended up changing this to be limit x approaching 2 of x squared over minus 4 over x plus 2. Same thing, very similar, but now if I do 2 squared minus 4 over 2 plus 2, still 0 over 4, still 0. So we can still evaluate limits. We don't always need L'Hopital, but it does help us out if there's a time where we really do need it. So let's try one last one. How about limit x approaching pi over 2? We're going to throw some trig in there. So 1 minus sine x over 1 plus cosine 2x. So we have to check to see if we actually need L'Hopital. So for these, it wasn't 0 over 0, so there was no L'Hopital. So what you end up doing here is, let's plug it in. So if I take a look here, 1 minus sine pi over 2 over 1 plus cosine 2 pi over 2, I end up having 1 minus 1, oop, I'm gonna get 0, over 1 plus negative 1 over 0. That tells us we have to use L'Hopital. Okay, let's go. So if we do this one, we will have limit x approaching pi over 2 of negative cosine x plus negative, oops, I need a 2, there's some chain rule, 2 sine 2x. Okay, let's evaluate. So negative cosine pi over 2 over negative 2 sine 2 pi over 2. This is feeling kind of funny. So I have 0 over, oh, if I look here, here's pi. Sine is 0 there as well. Oh my god, we gotta use it again. So I'll go one more round. Let's see if this works for us. So x approaching pi over 2. This will end up being positive sine x over negative sine is going to stay negative. So now negative 4 cosine 2x. So we will have sine pi over 2 over negative 4 cosine 2 pi over 2. So sine of pi over 2 is actually up here. We're up at 1. Cosine of pi is going to be negative 1. So we have negative 4 multiplied by negative 1. We end up getting just 1/4. So sometimes you need it, sometimes you don't. Remember, if you have the limit is 0 over 0 or infinity over infinity, use L'Hopital. What that means is essentially take the derivative of the numerator and denominator and redo the limit. Sometimes do it again. So you'll need to do it more than once. I hope you all are doing well. Please reach out if you need anything. Have a great day. Bye.